Chris is one of our most experienced Fusion 360 instructors. He works for Autodesk Platinum and learning partner Modena in South Africa. Chris is an electrical engineer by profession, and he's worked in the industry himself, which we hope will flow into this. And he's now supporting Autodesk customers by delivering training on software solutions such as Fusion 360. So Chris, thank you for joining us this afternoon. I know that there's more, hopefully there's more people than me who are excited to see the session here and look at that finalized drone. So I will actually hand over to you now to take us through the agenda and then start the demo.
Perfect, thanks Thomas. All right, how's it guys? So today we're going to be taking a look at Fusion 360. If you attended this morning session, you would have seen a lot of industry professionals having, shown how Fusion 360 has kind of helped them create their products, or, along those lines, basically Fusion assisting them to meet what they're trying to do. Here we're going to be looking at an intro to using Fusion. So we're going to cover stuff like how to draw and that sort of thing. And I'll get into all of what's on today's agenda. But first, let me just tell you a bit about myself. Thomas did a good job there, introducing me, but let me just take it a little bit further. So my name is Chris Quirke. Okay, so I work for Modena Design Centers in Durban. I'm what's called an applications engineer. And I specialize in Fusion 360, Inventor, AutoCAD, and Revit. So AutoCAD has kind of died off a bit. I've had another guy take over for me. So I kind of leave that one last. Still certified, so that's cool. I leave it up there. But the manufacturing space is kind of where I'm working in and staying in right now. So Fusion 360 is my most used software. I've got 7 years CAD experience. That would be including AutoCAD, AutoCAD Lights, Revit, all of those. And like I said, I was in the AEC team. I'm now in the manufacturing team looking at the manufacturing workspace. Okay, so let's take a look at today's agenda. So up next, we're going to look at how to create a project and creating a new file within that project. We're going to take a look at sketching and constraining. So we're going to obviously do some line work, some arcs, some rectangles, circles, that sort of thing, and constraining them so that that geometry doesn't move. Taking that, finishing that sketch, and then extruding it or revolving it. We'll also take a look at planes and what planes can do for us and how to obviously create them. We won't look at all of them. We'll just do a little basic intro to planes. And then lastly, project. So project is when you have an existing sketch, okay, and you want to project that geometry or copy, in a sense, that geometry onto another work plane. Cool. So yeah, that's our agenda. So let's get on into the demonstration. All right, guys. So this is Fusion 360. Now, before I start with anything, let me just quickly explain where everything is. So we've got our ribbon up at the top, which is the home of all of our tools. Directly above that, we've got this little bar up here, the title bar. This tells us what file we have open. On the left of that, we've got what's called the quick access toolbar. So you can see there's our quick access toolbar, and this allows us to quickly access some tools. For example, the data panel, which I'll refer back to in a minute. We've got the model browser over here. Okay, this obviously shows us everything that we've done in the model. Okay, so this will show us whether we've created components, new bodies, any sketches, construction planes, that sort of thing. Soon we'll end up with a file tree down here. Okay, a feature tree. Okay, which basically will kind of track the project history for me. So if I go create a sketch, it'll pop up with a little sketch down there. I then go and extrude that sketch. I'll pop up with a sketch and then a extrude symbol next to it, and so on and so on. As I add features, the tree will obviously get a bit bigger. At the bottom over here, we've got our visual controls. So we can actually go down to the display settings and go and set up our visual styles and control that to be shaded with hidden edges, visible edges only, or whatever we go and choose. Okay, so let's get back into that data panel. So the data panel allows us to do a number of different things. First thing we're going to use it for is to create a new project. So there's a button up at the top that says new project. So you'll click on that and you'll give it a name. Okay, and that's how easy it is to make a project. I've already created one called Digital Skills Camp. So if I just open up that project, you'll see I am now inside that project, and I can actually see what files belong to that project. I've already uploaded my drone model, okay, but later I'll obviously just show you basically how that is done. Okay, for now, I just want to actually take a look at the drawing space itself. So I don't need that data panel all the time. So we have the ability to actually go and collapse it to hide the data panel. So I'm going to click on this button so I can hide the data panel. It also gives me a bit more drawing screen, so I can actually, work a bit easier, and I can see what I'm doing, on a slightly bigger screen, not having that, unnecessary or somewhat unnecessary information blocking half my screen. All right. So what we're going to do next is we are going to take a look at how Fusion 360 works, by default. Okay. And what I mean by that is Fusion always has a drawing open. Okay, it doesn't care what that drawing is. It could be a blank drawing, it could be a drawing that you've obviously opened up, but it always has to have a drawing open. So if I were to go up to the top on this, title bar and move over to the right, I can see there's a little cross. And I can click on that cross and it'll close that, drawing down. But then immediately it opens up another one. Now you may think, okay, well, that little cross didn't do anything. It actually did. It did close the drawing, but then another one immediately opened up after it, another blank drawing. So Fusion, like I said, always has a drawing open. Whether it's blank or yours, it always has a drawing open. Okay, I can click on that little plus next to it, which will obviously create a new design, which is creating a new drawing. But neither of these two right now have been saved. All right, so it's probably not a good idea to work on a file that hasn't been saved. So we are going to save it. Okay, you don't have to. You could start working and create your whole design without saving it, but that's quite risky if your computer were to crash or the battery were to die or whatever the situation would be. So before I save this, I just want to expand the data panel again. Okay, so in the data panel, you can see that is my project that I'm currently in, and these are the files that exist in that project. But now I want to save this file. So when I say save on our quick access toolbar, it asks me, what do I want to call this? And obviously I'm going to give it a name. I'm going to call it first drawing. And I can verify that it is going to the correct location, which is my Digital Skills Camp project. I'm going to click save. So now I've saved that drawing to my project. And you'll see on the left-hand side, it popped up with the drawing, and now it's loading and it's loading. Now, what that loading means is that it's busy uploading that file to the cloud. So what it's doing is it's saving that file in Autodesk's cloud, specific to me, private to me, okay, only accessible by me. Now, the benefit of this is that if I were to now close Fusion, okay, and I go home and I've got my laptop at home or my tower at home or whatever setup I've got going, and I open up Fusion, or maybe I install Fusion and I log in as myself, I log in as Chris, obviously using my email address and password, I'll have access to any of the files that are in that cloud, which is everything in the side over here in this project. So all of these files are not locked to this PC. They are stored in the cloud, and I have access to them from any computer that I go and install Fusion and log in as myself. I'll be able to access that project and furthermore, those files. Okay, cool. The next little thing is this little C over here. It's just telling you who currently has that file open. So Fusion 360 has the ability to work with a single user storage or with teams. And teams give you the ability to collaborate on files and projects with colleagues or whatever the situation is. So currently you can see this file has been opened by me, and it's currently opened by me. And obviously if I work on it, I'll be able to save, and it's my file. So I'm going to click on this little cross, and you'll see there, in a while, that little C will disappear because I no longer have the file open. I still have a file open, the untitled blank drawing. Like I said, that's how Fusion works. So I'm going to go and double click on this drawing to open it up. Okay, and you'll see that that file will now load into my screen. Now, obviously, there's nothing on it, so we're not going to see any changes, but you'll notice that I now have the correct drawing open. First drawing. That little V1, okay, it could say V2, V3, V4, but that's obviously every time I've saved the model. Okay, so if I make a change to the model and I want to save it, I can obviously make that change and then click the save button, and that'll be updated to version 2. Okay, we'll obviously see, if we expand that, we'll obviously see some further information about the drawing, but also the versions. Okay, it's like a sort of like a history, okay, your version history for that part or that file. All right, so let's take a look at some actual, sketching and creating parts. So if I were to go and click on this create sketch button on our ribbon, okay, Fusion will then ask me which plane do you want to draw on, and what that's allowing me to do is either draw on what I like to call the ground, or the one side, or the other side. Okay, these planes have names. So the ground, what I call the ground, is the XY plane. This side over here is our YZ plane, and this one over here is our XZ plane. Now, I'm obviously calling them what I know they are called using these little colorful axes. So that little axis is red, and I know that the red axis is the x-axis. I know that the green one is the y-axis, and I know that the blue one is the z-axis. So currently on this face here, that is the xy face or plane. This is the yz, and this is the xz. Okay, so whichever plane or whichever face you choose to draw on will obviously, dictate how your drawing is going to be created. So I want to draw on what I like to call the ground. So straight over here on the floor, I'm going to click. You'll see that Fusion will orientate itself in a manner that I can now see, perfectly perpendicular to the face that I'm drawing on. Okay, I'm looking, we'll see the view cube just now, but I'm looking from the top. All right. Now what I can do in here is I can use my sketch tools, which have now appeared because I am inside a sketch. I can use my sketch tools, my constraint tools to create whatever I'm trying to create. Now, I don't have anything specific in mind. I'm obviously just going to try and create a sketch that's going to require me to constrain some things, dimension some things, and obviously extrude it at a later stage. And then we're going to take a look at project, like I said, from the intro slide. So let's start with our line tool. Now, we've got a line tool over here on our ribbon, our quick access tools. Okay, on the ribbon, we can quickly access some of these tools, but there is also a create dropdown. So if I click on that little create dropdown, you'll see I've got the line tool. Again, like I said, this is just your quick access, whereas these are more in-depth tools. You'll see there's a rectangle, but here there's actually 3 different types of rectangles you could use. Same for circle, same for arc, same for polygon. Now, some of the tools you won't find up here, you will have to expand the create button. For example, like arc. All right, so I'm just going to keep it simple. I'll stick with the line tool. So all I need to do is click on the line tool, and I've now started my line tool. You'll notice that my cursor looks a bit different. I'm going to press escape in 2 seconds, but currently you'll see that my cursor has a little crosshair, a little plus symbol next to it. It also has a little note saying place first point. So if I press escape, you'll see all that information goes away because I've pressed escape, which canceled the line command. So if I start the line command again, you can see there, it is ready for me to start drawing. It is showing me a little cursor. It is snapping to the grid. Okay, it is snapping to the grid. And if I press escape, that information goes away. So like I said, start the line tool. And I can click anywhere I want. I can click anywhere to place that first point. So let's say, for example, I'm going to click over here. Okay. That was one left click in that position, and you can see it started that line from that point. I'm now moving my cursor around at any angle, at any length that I want to go to. And Fusion is doing a few things. It's telling me, okay, currently that length of line is 55 point whatever, okay, and the angle is 150 degrees. As that changes, obviously the information updates. Another thing that it's doing is it will also, if I get into the perfect alignment, you'll see a little symbol just below the word, the numbers 50 over there. Okay, that is a horizontal symbol. So automatically, while I'm drawing, Fusion will try and constrain your model for you. Okay. Cool. So if I wanted to, I could go out maybe over here somewhere, just click. I don't have to snap to the grid. I'm just choosing to. Yeah, you can see there, I'm not snapping to the grid there. Middle, I'm not getting that little blue box popping up. So there's somewhere in the middle there. I'll click, I'll move out. And this is allowing me to go and left click
left click, and basically trace out the shape that I'm trying to draw. Okay. You'll notice once I close that shape, for example, I click, 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 click. As soon as I go back to the starting point, click, it'll close the shape. It'll automatically end the line command, not end the line command, but rather kind of, finish the line command for me and allow me to start the line command somewhere else. You'll notice here, as soon as it keeps trying to draw lines, but as soon as I click where I started, it doesn't try and continue drawing lines, but I'm still in the line command. I can still start drawing more lines. Okay, so I'm going to press escape to exit this. So escape. And I have been moving around and panning around, and I'm going to explain that in a second now. But I want you to notice that when I closed a shape, it turned blue, turned a light blue color. And that tells us that that shape is closed. Okay. Now, you may need to take a closer look at the shape. Maybe it's not turning light blue and you're not quite sure why. You may have not closed the shape. So let's, for example, say that in this corner over here, I never closed the shape properly. Now, obviously I have, but let's just pretend I didn't. What I could do is I could use my mouse and my navigation tools to take a closer look at that corner. So on the mouse itself, we've obviously got a left click and a right click, but we also have a mouse wheel. Okay, so that mouse wheel allows us to zoom in. And Fusion gives you the ability to kind of set this up the way you like it. So some software, when you scroll forward on the mouse, it'll zoom in. And when you scroll backwards on the mouse, it'll zoom out. You may want it to be inverted for whatever reason. You can. When you scroll backwards on the mouse, it'll zoom in. And when you scroll forwards on the mouse, it'll zoom out. That is a possibility, and you can set that up in your preferences. Okay. Right. So let's just say, like I said, there was a bit of an issue there. So I go zoom in to that point. Zoom in until you see the issue that's happening. Now, obviously for us, there is no issue, but if they weren't joined and connected properly together, that would be the reason as to why, the model wouldn't, the profile wouldn't be seen as a closed shape. All right. The next thing is maybe you'll zoom into a point, but then you'll need to take a look at a point just to the side of this, just to the right-hand side of where my cursor currently is. So what I can do is using that same mouse wheel, the mouse wheel can actually be clicked. So you can click the mouse wheel and hold it in, and you'll see my symbol will change, my cursor changes, and that's the symbol for panning. And I can pan across, and actually I'm left clicking and holding the mouse wheel in. Okay, so the mouse wheel button, click it in and move your mouse around. So I haven't let the mouse wheel go. I've still got that mouse wheel clicked in, and I'm able to pan around. So this gives us the ability to zoom out, pan to a different side of the model, zoom in, pan maybe further down to there. So you can navigate around your model quite easily using your zoom and pan tools. Okay, so that's it. On the mouse wheel itself, I'm clicking that button in, okay, clicking the mouse wheel in, and I'm panning around my model. Zooming in and out, obviously, would be used, I'll use the mouse wheel to do that. Okay, so the next thing is I can actually delete objects. And it's quite easy to do. So you can either go from left to right or right to left. They have slightly different abilities when you do that. So right to left. Okay, you see there's like a yellowish window with a dotted border, and left to right is like an orangish window with a solid border. Now, that's not Fusion just trying to be, cool and using some different colors and dotted lines versus solid lines. That actually has a purpose. It's to indicate to you that you're using a different selection method. So this would be your windows, your crossing selection, and this would be your window selection. Right? They obviously do different things. A crossing selection, anything that it touches will be selected. You can see there, I'm just crossing over those two lines. And if I let that go, it'll select that those two lines, as well as obviously the profile. If I were to go from the other way, you'll see it will not select it. It selected that point because it obviously fully enclosed that point. So crossing selection can just touch it and it will select, but a window selection needs to fully enclose the component Okay, let's just go to the side of here. Let's say it fully encloses that end line that's over there. And when I let go, it'll select that line. Whereas a crossing selection will select everything. So window is to select individual items. Crossing is to select anything it touches, anything it comes across, it'll select. Right. So I'm going to delete that. It deletes all of this. You can see it didn't select every line in there. Here you can see I've got every line about to be selected. Okay, it's crossing every single line in the model. Okay, delete. All of those, delete. This depends on which one you're more comfortable using. Crossing or window. Okay, so window versus crossing. Let's see, it's missed one. Okay, so I did want to delete that, so let's just quickly delete that. I'm going to pan and zoom back to my model in the middle. So you'll notice we've got a nice closed shape, good profile going. I'm ready to create some extra little shapes now. And what I'm going to do is I'm going to look at the circle and the rectangle. Now, I'm not going to go too advanced and look at all the different types of circles and different types of rectangles. I'm going to stick to the ones up at the top over here, which by default is our center diameter and our 2-point rectangle. So what I'm going to do is I'm going to draw a circle. Now, to draw a circle is actually easy. Okay, you just click the center point wherever you want that center point to be. You click, and then you move your cursor out, and you can specify what seems to be the radius from obviously the center point to our edge. But you can see there it is showing you a dimension right across the circle. So you can see there currently it's 24.5, right? But I could obviously extend that out as far as I want, and I can even type in a value. If I wanted to type in maybe 30, for example, I could type in 30 and press enter. Right, but I don't want to draw the circle next to my object. I want to draw my circle inside this closed area. So I'm going to go from here, maybe let's do it up here, to there. So I just wanted another small little circle inside the shape. And you'll notice that is now a closed shape inside a closed shape. Okay, that's quite important to note because that is going to come up just now when we are extruding. So then I'm going to create my rectangle, a 2-point rectangle. We've got to specify our first corner and specify our opposite corner. So very quickly and easily, we can create a rectangle with just 2 clicks. Okay, we can specify the sizes. I could type in a value of, let's say, 25, for example. I could press the tab button on your keyboard to lock in that value and jump across to the next value. And maybe let's put in 40 for that one. I could press tab because I've changed my mind. Let's make that one 30. Tab, back to this one, 25. And I can keep tabbing and jumping around and changing whichever one I want. Now, what's pretty cool about Fusion is if you do specify a value, it automatically places down a dimension for you. Okay, so if I were to type those lengths, when I was specifying the size for the rectangle, I typed in 30, tab, 25, and that's why the dimensions have automatically appeared. Now I'm going to get rid of them because I don't want that out there. I rather want it inside here, and I'm not actually going to use specific sizes just yet. So I'm going to draw my rectangle, snapping from there, maybe to there's a nice one. And I'm done drawing rectangles, so I'm going to press escape. Okay, so now I've got a closed shape with 2 closed shapes inside. I'm now going to finish my sketch. So I'm going to finish my sketch. And I'm going to show you the last little navigation tool, which is orbiting. So we've seen that we can zoom in and zoom out. That's easy. The mouse wheel itself is responsible for that. We can pan around, which is, clicking the mouse wheel in and moving your mouse around on the desk. Okay, but what we can also do is we can press and hold shift. So the shift button on our keyboard while we pan is actually the orbit command. So all I'm doing right now is I'm holding the shift button in and I'm holding the pan button in. So the mouse wheel, I'm using my left finger and I'm clicking that mouse wheel in. Okay, so I'm clicking that mouse wheel button in and I'm moving my cursor around while pressing and holding shift. Okay, so 2-hand operation. We've got shift and we are panning using the mouse wheel button. Okay, and you'll see that actually with that, I can see that that sketch has been drawn nice on the ground, flat on the floor. There's no elevation to that. It's just a flat sketch on the ground. Right. So once we've done that a bit, we can actually see the view cube on the top right. I can see the word top on it. I can see the word front. I can see the word right. Obviously, I can see left. There's back, and there's even bottom, which is underneath the sketch. So I'm going to orientate myself so I can sort of see the word top, and it's kind of straight. If I had it a little bit skew like that, it would obviously impact what's about to happen. So I like to get it a bit straight over there so I can see the word top. I can hover on the view cube where it says top, and I can actually click on it. And what that does is it orientates my model back perfectly perpendicular to my sketch plane. Okay, remember, I finished the sketch. I'm not inside the sketch anymore, but I'm looking at the sketch. So we've seen we can zoom in, zoom out, pan around, and orbit. Okay, so that's using the mouse wheel. Zoom in, zoom out, roll forward, roll backwards on the mouse wheel. Click the mouse wheel in and move your cursor around. We'll obviously pan, and shift while panning will allow us to look around inside the model. Okay, to orbit the model. Cool. So I'm going to click on top again. Click here on the word top so that it orientates my model perfectly. So I'm looking from the top. Right. I've realized that there's actually some extra things inside here that I want to do. Maybe I need to modify something. Maybe I need to put in some dimensions or even possibly some constraints. So let's go take a look at our feature tree that I told you about. So down at the bottom over here, we've got our sketch. And I can right click on that sketch and I can edit that sketch. So you see where the model tree becomes quite useful is that you can actually go back in time, in a sense, and edit a sketch that you've created. So I'm going to edit the sketch. And I'm now inside the sketch environment again for that specific sketch. And I can use a number of different modifier tools, for example, fillet, chamfer. And we'll look at the fillet tool just now, but chamfer, trim, extend, these allow us to cut lines away. Let's say, for example, we had a line going past, maybe like this, and we didn't need that line protruding all the way out. We could go use our trim tool and we could trim out that little section of line. Okay, you can see where it's trimmed back till the line where it intersected. So I don't need that line at all. I was just trying to show you some of the tools in here. So there's obviously offset, scale, break, extend. There's quite a few. So you can use your modifier tools to modify this. So let's say, for example, we wanted to use the fillet tool. Now the fillet tool will take a pointed corner or two lines that meet at a corner and it'll round them off at a radius that you specify. So I'm going to start my fillet tool and I'm going to go click on two lines. This line and this line, they meet nicely at a corner. And you can see there it kind of previews a bit of a, kind of shows us what it's going to do. I'm going to click. And you'll see there, I have the ability to use this arrow or a value, the actual value that we can input, but I can control how much of a fillet I actually want. So let's just go with 10. So I'm going to type 10, press enter, and you'll see I've now filleted that corner, given it a nice rounded off edge curve, and it's put a dimension there for me. Okay. We can also actually just, hover on a line, left click and hold, and drag that line around. Now that's only possible because this line is not constrained. I have not, given a set distance between these two. If there was a set distance between these two and I tried to move this one would move with it. And that's because there's no set distance between these two. And like I said, if there was a distance between there and a distance between there, just by moving that one line, it would maintain that distance between all of these. Okay, and that's bringing us to our next topic, which is constraining. So you can constrain using a number of these different tools up here, or using the dimension. Now, you'll notice there's quite a few little symbols popping up all over our drawing over here. Okay, so these symbols obviously have different meanings and they do different things. For example, on the constraining side of things, we've got the horizontal constraints. This constraint over here is constraining this line to always be horizontal. This line cannot change its angle. Right. The next line over here, you can see this line over here and this line over here are perpendicular. And you can see, you can sort of see it, you can kind of see that they're highlighting. It's not so great. I don't know, with this background color, we can't see it so well here, but it's sort of highlighting those two lines, telling us that those two lines are perpendicular. Now, if this line is perpendicular to this line, and this line is horizontal, indirectly, what that means is that this line is actually locked vertical. Okay. And if these two are perpendicular together, okay, which you can see here, those two, okay, then technically this has been locked at a horizontal, orientation. Perpendicular, so this is vertical, and you get the idea. It obviously goes all the way around. So the model has been well constrained. It is not fully constrained, but it has been well constrained. We can furthermore use these constraints to sort of, fully constrain our model. Now, why do you constrain in the first place? Okay, constraining is so that if you wanted an object to move, or if you wanted to maintain a distance between two lines or 2 points, or a point in a line, or whatever the situation is, you can do that. You can use dimensions to do that. You can use these constraints to do that. And what that allows us to do is model a component, and it would not distort its shape unless we went in and changed one of the dimensions. Okay, or changed one of the values of a distance between two objects. We can also reference objects together. So I could go and I could say that maybe this side over here is 10 millimeters, and this side over here needs to always be equal to this side. So let's say this was dimension 1, for example. We could go make this line over here equal to dimension 1. So whatever dimension 1 is, this guy will match. Okay, so that's where constraining gives us that ability. Putting dimensions will allow us to go and make one dimension change that updates pretty much. It's possible to have one dimension control your entire sketch. Okay, so let's take a look at the dimension tool. So our sketch dimension tool. This is a dimension tool used within your sketch environment. So I'm going to start my sketch dimension, and like I said, I can click on a line. Okay, I can click on a point. I can do a dimension between a line and another line. Okay, and I can put it down. I can confirm that value of 65, so I can press enter. I can do a dimension between a point and another point. You can see there 35 and press enter. Or I can do a dimension between a point and another line. I can put that value down. You can see that's 43 point something. So that's not quite a nice round number. So let's type in 45 and press enter, and you'll see the sketch will update and suit that 45. All right. So dimensions also can just click on a line and you can place it down. You don't have to say what is the distance between that point and that point to give this line a dimension. We can just click on the line itself and put that down. And instead of 45, I want this dimension to always be the same as this dimension. So you can see there, if I hover on that one, it's D5 is 35. And this guy over here is 45. So with it highlighted, I could either just press delete and clear it, or I could go up to the top here to 35, and I can click on 35. And what that does is it puts that value, okay, that name, D5, in this dialog box. And when I press enter, it'll make these two always equal. Now, yes, I could go and use one of the constraints to do that, which is our equals constraint. Okay, and I could say equals this guy, and they'll be the same. Okay, that is a possibility, but I like to use dimensions. I'm showing dimensions, so I'm making reference to that. Now, if I go here and I double click on this 35, that is how we edit dimensions. You double click on the text. I could go type in 45, for example, not 35. And you'll notice that the bottom one would have updated as well. Okay. So we have that ability. I can go maybe dimension, from there to there. And I'm going to say this is supposed to be 10. I could dimension from there to there and say this is always supposed to be whatever that 10 is times 2. So I could click on the 10 and I could start building formulas. Now I'm not going to go much further than this with the formula story, but there's D8, okay, which we know is 10, star, which is times, and it'll turn red. And that's because currently the math doesn't make sense. If I said 1 plus minus 1, that is not a math equation. But if I said 1 plus 1, it makes sense. If I said 10 times 2, it makes sense. So currently 10 times what? There's something missing in my equation. So let's say 10 times 2, and you'll see it's no longer red. I can press enter, and that distance between there for that line will now be 20, because 20 is 10 times 2. So that's how it's working. If I were to go and edit this text and make it 15, it'll become 30. And if I made that maybe 12.3, it'll do the maths and figure out what this needs to be double that. Okay, so it's gonna make it 10 again. Now, if I were to take this line and drag it up, can you see how it is actually changing how everything works? It is keeping everything perfectly spaced apart based on the dimensions I've given it. And to do that, what it's doing is it's extending or shortening this line on the side over there. If you watch, you can see there, it's going up. Okay. I can also obviously go this way. Okay. And what this is telling me is that my model is not fully constrained yet. Things can still move around. Okay, my dimension is fully constrained because it has a my arc, my fillet has a dimension. Okay, this guy over here cannot go out. It can. You'll see. I'll explain what I mean now. But it cannot go out more than 65 from this line. So you got to go put your dimensions all over the place to fully constrain your model. And once a line or an object is fully constrained, it'll turn black. So black indicates to us that there's no more movement, and you can see that line can no longer move left or right in this situation. You'll see this line cannot move left and right because it is fully constrained in that direction. I can still move up and down. Yeah, and that's because I have not built many more parameters or many more dimensions in here. Okay, and I mean, I could go and say, well, this line over here is always supposed to be 30, for example. This one over at the bottom over here is supposed to be, I don't know if I should be able to do this, should be 50. And then if we go put a dimension from there to the origin, because the origin is fixed in place, you can see there at 50, that looks good. Can you see how more of the lines are starting to, be fully constrained? If a line is not black, I can take it and try and move it and see, okay, why can you move? Because there's a dimension over here on this line that's missing. So I can go put a dimension on that line, start my dimension tool for that line, put it down and tell it to be 10. Can you see now, I cannot move that up or down. I cannot move this left or right. But this one still can move left or right. And this one can still move left or right. So you got to further go and put in more and more dimensions until everything stops moving. So maybe 40, maybe a distance from there to there could always be the same as this distance. Enter. Right, and you can see that slowly things start to get constrained. Objects like a circle can sometimes be interesting because it has got a dimension for it, a diameter. But why can it still move around? Because the origin, the center point, has not been dimensioned or referenced to anything else. So if I go from the center of the circle to the edge, I say that's supposed to be 15. And I go from here, from the center to that one, and I say that's also supposed to be 15. Now you can see it's fully constrained. And obviously there's one more line that is needed, but you guys get the idea. And I've now got a almost fully constrained model. And I can finish my sketch, and there you go. Can orbit, can pan, can zoom around, do whatever I need to do. Okay, cool. So now we can take a look at our extrude. Okay, so if we wanted to extrude this shape, okay, we'll extrude this sketch, should I call it? You can see that when I closed that sketch, it became a solid item. It became a filled closed profile. Now, if I start my extrude tool, Fusion is not going to automatically assume that I want to extrude this. Because there are multiple closed shapes, there are technically multiple closed profiles, meaning that it's not going to automatically choose a profile for me. It's making it my decision to choose which profiles do I want to select. So Fusion's quite nice in highlighting in blue what currently, what is expected of us next. So we got to go select our profiles. So let's, for example, say I want to go select this profile here, or this profile here, or this profile here. I'm going to do the circle first. And you can see there I have now selected that profile. Are there any more profiles you want to select? Maybe the rectangle. Okay. Then I get a little blue arrow, or I get a value that I can type in. So I'm just going to move this little arrow, drag the slider, drag it up. And you can see I'm extruding both of those profiles equally to a certain height that I am specifying. Let's say I made a mistake. Okay. Let's say, I didn't want to actually go and, select that and that. All I need to do is click on it again. Okay. So I can extrude it, add that to it, remove from it, add this to it, maybe remove that circle. You get the idea. Now, if you notice, with those two selected, that looks pretty good. But if I go and actually click inside this closed area as well, it just looks like one solid extruded shape. There's like no definition, no distinguish. You can't distinguish between the circles, the rectangles, and obviously the outer border shape. And that's because I'm extruding everything. So I can obviously deselect that circle and deselect this. And you can now see they are actually being represented as cutouts in our shape. So I'm going to press escape. I'm going to start my extrude tool again. And this time I'm not going to click inside these circles, but I'm going to go straight inside this shape, this big empty shape. And you'll see that it's picked up all those closed areas and ignored those closed shapes inside there. Yeah, and I have the ability to go up or down. But let's just say I'm going up by 10 millimeters. Okay. I've got some other things that I can do. I can change the distance manually from this dialog box. I can change the taper angle if I wanted to. Let's see there. Change the taper angle. Okay, I'm going to leave it at 0. I also have the ability to change the extent type to distance to object. There are no other objects in here. All wouldn't make sense right now. So distance is our real only option. But we can also change the direction we're going. Okay, maybe you wanted to go in two directions, but 2 ways, up and down, certain distances up, certain distance down, or maybe symmetrically. It needs to go up and down equally the same distance from the sketch you've made. Yeah, so I'm just going to leave it to one-sided. That's perfect. I'm going to go up maybe 15 mils is fine, and I'm going to click OK. Right, and I've now created a nice little extrusion. Okay, very easy to create an extrude. I'm just going to undo, because what I want to do next is use this sketch for my revolve example. Yeah, so I'm going to create a revolve. So there's my revolve tool up at the top. Start the revolve tool. It then says to me, right, you need a profile and you need an axis. So I'll explain axis shortly, but profile, we've got experience with this. What are we trying to revolve? Which profile are we trying to revolve? I'm going to go with this one in here, this little rectangle. Right, I'm just going to orbit around so I can see the edge I want to use. Okay, and it now says select an axis. Now the axis can be an axis in the project, which is our X, our Y, and our Z, which we saw earlier being represented by red, green, and blue. Okay, but what I could do is use any axis that is actually a straight line. So instead of using this green, this blue, and the red, I could use any line in our model. Okay, and the line would be an axis. Some edges or some lines in this wouldn't work because it would cause the shape to kind of fold back on itself, which is not possible, okay, with a revolve. But if I were to use this line or this line, for example, it'll take this shape and revolve it around the line I choose. So firstly, I'm going to choose the edge of the actual profile itself. And when I click on this, it'll revolve that sketch or that profile around the axis that I chose. And if you look, that axis is actually perfectly in the center of our revolve. It's taken that sketch and it's revolved it all the way around that center point, being the line we chose. Right. So let's just clear the axis using a little X over there. And instead of choosing the axis right on there, I'm going to choose the axis a little bit away. So we're going to have a bit of an empty space over here. Now what's going to happen is it's going to revolve that empty space as well, allowing for us to have, a hole for a bolt, a pin, whatever is supposed to be, through there. Okay. We can also control, how much of an angle we give, which direction it's going, anything like that. Cool. So I'm just going to click OK so we can confirm that and actually take a look. And you can see there is our revolve. Now you'll notice our sketch disappears because the sketch has been used by this feature and has been consumed. Okay. It just means it's been switched off. It's still there. We can still use the other features inside it. It's just currently been consumed by the revolve. Okay, so I'm just going to undo. There you go. We're back to our sketch. And I'm going to create an extrude again because the next thing I want to show you involves planes and project. Right. So we've covered sketching, constraining. We've covered the extrude tool and the revolve tool. I now want to take a look at planes and our project tool. So under the construct panel on our ribbon, we've got planes, different planes that we can use. There's an offset plane, planar angle, tangent plane, mid plane, some really awesome tools in here, and they allow us to do some really cool things. So let's just take a look at a few of them. I'm not going to go through all of them. Maybe I'll just look at 3 of them. So mid plane, okay. Mid plane allows us to create a plane between 2 faces. So we could go and choose maybe this face over here, pan around, or orbit around, and choose this face over here. And what it'll do is it'll create a plane perfectly halfway between those 2 planes, okay, or between those 2 faces. Our mid plane. Yeah, I'm gonna just click this little cross because I want to do a slightly different example. But what we can also do is we can go and click on maybe this face and this face. And it'll create a plane at a 45-degree angle in this case, because those are 290 degrees, but it'll create a plane perfectly halfway between those 2 faces. Okay, so they don't have to be opposite, they can be adjacent, but you can see where the mid plane is quite useful. You can create your own planes that you can sketch on. Yeah. And if I create a sketch on that plane and I draw a circle and I extrude it in both directions equally, you can understand the benefits that would have. Yeah. So I'm going to click cancel because I don't want to create that mid plane. I'm going to expand the construct tool and the planes tool, sorry. And I'm going to take a quick look at the plane at angle. So plane at angle will allow me to click on an edge. Okay. And also I can go and set an angle for this, so a rotation angle for this. So instead of just creating a plane, a boring flat plane, I can actually turn this a bit so that now I've got a plane around an edge at a specific angle. And I can obviously specify that angle, 45 degrees, type in the angle, whatever, maybe change my mind, give a different edge. Okay. And you can use that little grip like I did. And you can see I've created a plane at an angle around an edge. So if I sketch now on that face, I could obviously extrude towards the shape, okay, at an angle. Cool, so I'm going to click cancel. And the one we're actually going to look at is the offset plane. So there's our offset plane, the first one, okay. And what that tool allows us to do is create a plane that is offset a specific distance from a face. So I can start my offset plane. I can click on the face I want to offset from. And it'll give me a big plane perfectly flush with that plane, with that face I've chosen. But I can use the little arrow to drag it up or type in a value if I really wanted to, a certain height up. So 20 is fine. I'm going to click OK. Now I've created a plane that is offset by 20 mils from that face. Okay. That gives me the ability to then create a new sketch. Okay, so we've looked at creating a sketch. So creating a new sketch on this plane, the newly created offset plane. You can see there, if I look in a slightly isometric or 3D view, the plane I'm drawing on is 20 mils above the object. There's my plane. See there? 20 mils above this object. So if I were to get back to my home view, if I can just try and get my new cube, nice, there you go. Get back to my home view. Whenever I want to sketch, for example, a rectangle, you can see that rectangle is above the model. It's not on that face, it's above the model. Okay. Right, so that's pretty easy. It's pretty easy to understand as well. But what I want to show you next then is not just a rectangle that's been, drawn on a plane above the original shape, but rather I want to go to create, go down to project, and you can see there is a project tool and an intersect tool. So if I use my project tool, what this allows me to do is allows me to take geometry that I can see below here and project it up onto the plane that I'm currently working on. Let's say, for example, I needed to, recreate this outline, this outer shape on this plane that I'm drawing now. I could use project. And I could go click on each and every single little line that's inside here and project it. I could click on the face, but then it's going to project these inner circles as well. And maybe I don't want to do that, inner circle and rectangle. Maybe I don't want to do that. Maybe I just want to project this edge, this edge, this edge, this edge, and this edge. Maybe just those. And if I look in a 3D view, you'll notice that it's actually projected those edges up onto my work plane. There they are over there. And if I click OK at this dialog box, it will confirm that. And you can see there, I now have that geometry projected up onto the plane that I'm currently working on. Now, the point of this is that if I hadn't projected edges, it's quite difficult to snap to it. Now, obviously, this time it's making me look silly here, but it is snapping to the grid. It is not snapping to that line. Okay. Whereas with this, it's snapping to the line. You can see a different symbol appearing. I can snap to the endpoints or actually anywhere along that line, not just snapping to the grid. Somewhere here, I did draw one that is like halfway on a grid. I don't think I did. I projected that one anyway. So, but if I just look and I found it, you'll see somewhere. I'm not going to hunt for this all day, but somewhere I did actually draw one like that. So maybe the circle is a good example. You can see there, what if I want to snap to that circle? It's kind of snapping everywhere, but on the circle. See, it's not snapping to the circle. It's jumping to the grid, but not to the circle. So if I just go create, project, start the project tool, click on the circle, click OK, I've now projected that circle. So you'll see on our sketch, we've projected the circle. Okay, but what that means is I can go and draw a line and it'll snap to the circle rather than just anywhere on the grid. It'll snap to the edge of that circle, snaps to the center of the circle too, but that was what project is used for. Okay, I'm just going to quickly set up another little example of yours. I'm going to say finish sketch, and I'm actually just going to go and delete that sketch from our tree at the bottom. I'm going to create a new sketch on this face. I know I'm going quite quickly, but it's just to set up a little quick example. I've created a circle on that face. I'm going to extrude it. And when I extrude it, I'm going to send it up a bit, about 22. Let's go up 30. Okay. Now that I've got this object protruding out of that shape, okay, I'm going to construct an offset plane from that face up. Obviously not the full distance. I'm just going to go up maybe 15 mils. That actually looks pretty good. And I'm going to click OK. So you can clearly see there that that cylinder, our work plane, sorry, is cutting through our cylinder. So what that means is when I create a sketch on that work plane, we can go and use our intersect tool. Yeah. So create, project or intersect, we're going to use the intersect tool. And you'll see there, the cylinder, does it intersect that shape? Yes. So when I click on it, you can see it's projected it, and I can click OK. One of the best parts about the project tool is if I go back to the original sketch, okay, let's actually just finish this one. If I go back to that original sketch, which I think is this one, and I edit that sketch, and I decide that that circle needs to be a bit bigger, I click finish sketch, you'll notice that the projected sketch, the projected circle has increased as well. That's another benefit to using the project tool. Okay. All right. So then our last two tools that we're going to look at then is the fillet and the shell. Now, to look at those quite nicely, I think what I'm going to do is just draw another shape next to it. Actually, I'm going to start a new file. Why not? So I'm going to start a new file with nothing in it. I'm going to click Save. I'm going to call it second drawing. You'll see it'll appear. Now it's loaded in, and it's obviously saved from the cloud. Same story as before applies. I can access that from any computer that has Fusion that I log in as myself. I have both files open, and that's why it's obviously like that. I'm just going to close this one down. I don't need this one open. I'm not going to save the changes. There's no need for me to save these changes. Yeah, so I've got my second drawing open. So we're going to look at the fillet and the shell tool. I'm going to create a quick little sketch. Nothing too fancy, just a fast little, it's a bit of an edge angle there, which is fine. I'm not too worried about constraining. I'm not too worried about the angles. It's all perfect. This looks great. All right, and I'm going to say extrude that shape up a bit. Say okay, and I'm now going to take a look at the fillet tool. So the fillet tool, similar to the way the sketch tool, or similar to how we use it in the sketch tool. Okay, in the sketch, we filleted one of the edges, and we could have done that. Okay, if I went in here back to my sketch and I filleted one of these edges, so there and there, and that looks good. I'm going to click finish. Can you see how it's actually gone and filleted my extrusion? But how would we fillet these top edges from that sketch? It's not possible. So we could use the fillet tool as a feature, and we could say start the fillet tool, and we could go and select the edges. So you can see there I've got that whole edge. Okay, got this one, maybe those are all the ones I want. I'm going to use this little slider and drag it down. You can see how I am filleting those edges. Very quickly and easily, I've created a curve to those edges. Okay, so I can click OK. Created a fillet. I can go and start the fillet tool again. Click on this edge, maybe on this edge, and let's give it a bit of a fillet. Now, maybe I want to add another edge. I can do that. I can press and hold Control and click on the edge, let Control go, and you'll see it'll add that edge to the fillet. You can click OK again, and you'll see I've nicely gone and filleted some edges on this. But more importantly, if you look at the feature tree at the bottom, you can see there are two separate fillet features. So there's feature 1 and feature 2. Okay, so they're done separately. Right, well, they can be done separately. So up next, I wanted to show you the shell tool. So the shell tool allows us to take a component and make it hollow. You can see there from the illustration, there's a little box, and they've used the shell tool and removed two faces facing us. And they have obviously kind of exposed the shape and giving it and showing its thickness. So we're going to do the same thing. So I'm going to start my shell tool. I'm going to go and remove specific faces, specifically the bottom, and maybe the side. Okay, it's chaining a whole bunch of faces together. Okay, that's why it's kind of trying to pick up the whole shape. But if I go turn tangent chain off, you'll see I can pick up individual faces here. So I'll do that. I'll pick up this face. Maybe I'll take this edge and I'll take this face. Okay, those are the faces I want to remove from my shell or from my object. I'm then going to give it a bit of a thickness. You can see that I'm just dragging that slider across. So from the underside, you can see I'm actually controlling how much of a shell I'm giving it. Yeah. So let's just give it a nice 1 mil thickness and click OK. We can set inside or outside. Sorry, we can go inside or outside or use both. Okay, but we're going to go inside. Inside 1 millimeter is perfect. Click OK. There you go. I've created a nice shell of this object. I've basically removed those faces. And you can see how it's respected that there was a fillet. So it has maintained the thickness throughout the curve of the fillet. All right. And that's part 1 concluded the basics and intro to Fusion.
Thanks, Chris. That's a very comprehensive workflow. I thought I would just jump in here because I saw that we obviously covered quite a lot of ground now in going through this this whole workflow. And I saw there were some questions on the chat, so I just thought we could start with the some of the high-level comments. There's been some feedback about the pace that we walked through this quite quickly. And I want to underline that that's actually by design, and it's the event organizers, in other words, me, that you need to point the fingers at. I've given Chris, we gave Chris a bit of a short time frame to get through all of the content. We are recording the session though, and as you may have seen in the chat, there is going to be a link sent out once we've completed day 2 of our event tomorrow. Then everyone will get a link to the different sessions. There's also, the data files of the drone is also available from Autodesk. So then we can include that in the message. What we will do is that we will take a short break now just to stretch our legs, etc. in a little while. And then I think when we come back and do part 2, then, feedback accepted. We'll take a bit of time from the Q&A session, and I'm sure that Chris can, we'll do the next step a bit slower. So I'll relax my time pressure on him. Apologies for that. We just wanted to go through all of the content. But with that said, does anyone have any immediate questions that you'd like to address now? I think there was one about the measurements, wasn't there, in the chat?
Yeah.
There
was a question about measurements. Yeah, so someone, I can't remember who it was. I'm not going to scroll all the way back up now, but someone asked about, do you need to know the measurements before you start drawing? No. So you saw there, I think you asked this just before I started editing the sketch. So, but if you create a sketch and you draw whatever shapes that you want to draw, at any point in your design, can you go back to any sketch you've created and go and edit that sketch and make changes? You can change dimension sizes, depending if you've created formulas and that sort of thing. Obviously, it'll affect other dimensions. But at any point, you can go back, add dimensions, remove dimensions, change sizes, rechange the sketch if you want. So to answer your question, no, you don't have to know the exact measurements from the get-go, just the rough shape that you're looking for, and you can edit it. Yeah.
Cool, thank you. Before we jump into the next part of the demo, I saw that there were a few more questions that were put in the chat while we were on break. So I just thought I would summarize a couple of those for everyone's benefit here. So there was a question around other opportunities to learn Fusion and learning resources, etc. So there's basically 3 options in the Autodesk world, or that we would recommend. One is that Autodesk themselves have a huge library of free learning content that's available to anyone, anyone who wants to learn their software. There's lots of useful information on Fusion, but there's also on their other software products. What's really good with that content is that it's also aligned to Autodesk certification exams. So it can actually be used to prepare for the certifications that are available on the software. Now, self-study is, of course, not for everyone, me included, actually. I know that for myself. So sometimes we prefer to be guided by an experienced instructor, someone like Chris, as an example. So then we have Chris's company, Modena, is a learning partner for Autodesk. And we have plenty of other learning partners in many countries across the African region. You heard from Samia Shelby this morning, for example. She's a learning partner in Tunisia, and we have them spread in Nigeria, Kenya, you name the market, and we are present in most of the countries. They offer instructor-led training. It could be delivered virtually or face-to-face in classroom. And part of the follow-up will be to recommend some of those those resources and the partners. And then the third option is, of course, if we do events like this. So this today and tomorrow is we're basically scratching the surface. We're hoping to give you a starting point, show you what's feasible, particularly how easy it is to get started with Fusion 360, I'd say, especially again, going to myself as someone who's not a designer engineer by education or profession. Even I can kind of get some of the basics going. So that's what's so intuitive with this tool and why we're focusing so much on it, because the ease of which basically anyone can get started. So watch this space. We may be planning, without revealing too much, but we may be planning follow-up sessions that would also then follow up with training. So those would be the three options. I hope that gives a little bit better overview. I know there was a specific question about preparing for certification, but those three would be venues towards that as well, with the free learning content for self-study and what I would recommend always the learning partners that are out there, and then some special events that Autodesk and their partners organize. Yeah, and we will include these links again in the email that we send out with the recordings and the information generally from the event. So hope all that makes sense, and sorry if I'm taking up a bit more time than intended there, but hopefully it makes sense. I also saw that there was a specific questions around the model in terms of the file type, etc. So Chris, could you just say a few words about that, how applicable it is for other CAD software?
Yeah, sure. So how Fusion actually works, and I think I did say it earlier, but it's a cloud-based software, so everything's stored in the cloud. But what you can do is you can export it locally as a number of different file types, and I'm not going to try and list them, by memory, because there are a lot. But I know that there's SAT, for example, is a very common one. It's one of the most used ones here, that I've used in the past. So yes, you can export it as the correct file type that is readable by that other software you're talking about. I know SAT does work with AutoCAD. SolidWorks I have not got much experience with, and CATIA as well. But I do know that, yes, you can export it as other file types that are readable in other softwares, yes. And I can even show you that in this next little session that we do before I start. I can show you where the export option is. Yeah.
Cool. Well, I mean, that's maybe a good segue, because I think those were the main questions. I would once again encourage everyone to use either the chat or the Q&A as you see questions. And Chris and I had a quick chat in the break, and he'll go through the next part of this workflow now, a bit slower pace to give everyone a chance to follow along. And yeah, we look forward to the next part. So thanks, Chris. I'll hand it back to you.
Cool. All right, so let me just quickly get this going over here. All right, so in terms of the chat, I can't see the chat anymore. So Thomas, I'm gonna have to ask that you just, I don't know if there's like an urgent question that someone has, just, interrupt me there.
Absolutely, I'll keep an eye on it. And if you see me appear
Perfect.
on screen, then you know that there's something going on, so.
Perfect. Yeah, so that should be fun. In terms of my screen, you can obviously see Fusion, right?
Sorry, yes, we can see it.
Okay,
and
cool.
hopefully
Awesome.
I think it's zoomed in a bit better now. So yeah, hopefully that also, I know that was another point. So this looks good on my screen at least. So if anyone still sees it a bit blurry, just put a comment in the chat and we know, but I think it looks more zoomed in now.
Okay. Cool. So just to quickly discuss, what we previously looked at. So we looked at basically a new file and how that works, and I think we got that. That was quite good. Creating a sketch, that's pretty easy, pretty simple. Modifying that, adding dimensions and constraints and that sort of thing. That was all the fundamentals of drawing. So we're going to sort of incorporate that, but at a little bit more of an advanced level. Not too advanced, it is still quite basic, using the drone model. And like Thomas said, this file is actually going to be made available to you guys, and you can download it and try all the steps that I'm doing, from the video. So yeah, I mean, you're welcome to do that. But we will be touching on a couple of the tools that we've, just looked at. So we're going to look at creating a new sketch. We're going to look at on a plane. We're going to create some projected geometry, some extrudes, some more sketches that are now cut through an existing sketch, extrusions that are cut through other extrusions, the fillet and the revolve, and some basic things like that, applied to an actual object. So yeah, I mean, let's jump right into that. So I've got that data panel. I'm just gonna I'll leave this here. It's going to be a bit in the way. There you go. Okay, I'm going to minimize it. So Thomas, if you do pop up, you're going to have to just talk for me. So that's perfect.
Yeah, of course.
Cool, awesome. So yeah, I've got the data panel open again. There you can see on the left-hand side of Fusion, there's the data panel. And that's again showing us our project and all the files within it. So you can see there's our first and our second drawing that I was doing. And then there is our drone model that I've uploaded. So I'm not going to upload this drone model again, but I'm going to basically show you how to do that. So you will obviously download that drone model from wherever you get shared to you. And once you've created your project, you can click on the little upload button. Right. It then says to you what files do you want to upload. So you can either drag and drop, or you can click select. And if you click select, you just have to navigate to where the files actually obviously are. So for me, I think it's on my desktop. There it is. You can see it's the drone model. Okay. It's a F3Z file. And that's the file type that I can actually bring in. Okay, I can say open, and obviously just do it, and it's ready there to upload. Now I'm not going to upload it, like I said, it's already here, and it'll upload the file. Now you can do many files if you have like a lot of different F3D or F3Z files that you want to upload. You just go select more of them, and when you're ready, you can upload them using the upload button. Okay, it takes a bit of time. Obviously, it's got to upload and publish those files to your Fusion account, but yeah, that can be done. So I'm just going to click cancel because it's already here. And then obviously to open up a drawing, just double click on the file you want to open. So drone model is the one, double click, and it's going to open up that model. It takes a bit of time, and there you go, pops up. Now, this is basically what we're going to work with in this next little session. So we're going to be creating some elements inside here, and I'm not going to reveal the secrets and show everything right away. But we're basically going to be drawing the top plate, okay, the top plate for our drone, and then later we're going to go and revolve a little protector for the antenna. But we'll get into that, and I'll see that a bit just now. So what I'll do is I'm going to draw this first step. I'm going to create the sketch and project and all that, and then I'll pause. And if there's any questions, obviously we can cover those. Okay. Yeah. So let's get straight into it then. So you can see there, I'm using my shift and my middle mouse wheel button to pan around. Okay. It's pretty good. Let's stop killing the bandwidth over here. Just cut my video there. So we've if you use your shift and your middle mouse wheel, okay, we can orbit around. We can actually take a look at the model. Again, zooming in, scrolling forward, zooming out, scrolling backwards. Like I said, from the preferences that can be switched around. But so I like to just get to a kind of nice view. I like to work sort of like at this angle where I can see this plane, I can see that plane, but I can also kind of in 3D see what I'm working on. So I'm going to create a sketch. So I'm going to start my sketch tool. So there's my create sketch option. And again, it's going to say to me, which plane do you want to work on? Now I could go choose that ground, like I said, the one side or the other side, the X, Y, Y, Z, all that. Or I could go and choose a plane that has been created. Now, before I actually choose this, how was this plane created? How did I actually get to this point? Right? What I did was I created an offset plane, which I covered already, from this bottom face over there. So I've created an offset plane a certain height up. And there it is. And that's the one I'm going to choose to actually draw on. So I'm going to select it. And you'll see that Fusion orientates us to kind of look from the top perpendicular to the plane that we are drawing on. And you can see that little grid, okay, is actually indicating where we are drawing. So if you look there, that little kind of line that's going across here, that is our sketch plane. And you can see it's definitely above the existing, bracket or plate, whatever you want to call that. And we can see that is the height and the elevation that we're actually drawing at. Okay. Now, if I go back to my view cube and I click on the word top.
Chris, sorry for interrupting you again. But I see there is a question about how you toggle visibility of the plane, more like inventor is what it says. Does that?
Let me just quickly pull up the chat there. When you say toggle visibility, you mean obviously switching it on and off?
I would imagine that. Yes.
Nope, perfect. So in Inventor, you can go to the model browser on the left-hand side, similar to Fusion, which I'll get to, and you would right-click on it and you could say visibility, and you'd obviously turn that on or off. If the plane is currently visible and you want to switch it off, I think you can right-click on the plane and visibility is there. There's also some drag shortcuts. I think Alt-V is another shortcut, but anyway, let's look at Fusion, not Inventor, right? So the planes themselves, let me just get out of this again. Minimize that. I don't need this guy. Try to get him out the way here. So in terms of the actual planes, if they are visible and you don't want to see them, or if they're there and you do want to see them because they're not currently visible, you can actually go to your model browser on the side, find where it says construction and expand that. And you'll see I've created a plane called top plate, and I've created a plane called antenna. So let me just quickly create another one quickly. So another offset plane. I'm just going to go down. Okay, there it is. Go down, and I'm going to click OK. So very quickly, I've created another plane at the bottom. I'm going to delete that one shortly because I don't need it. It's just so I can show you that plane 3 now exists. I can switch these planes off if I don't need them. Okay, and I can obviously switch them on if I do. I can delete them as well. Okay, and if they are off and I do need to use them, it's not a problem because I can start my sketch and I can go and actually click on the plane from our model browser and it'll start the sketch on that plane. So it works very similar to Inventor. They've just kind of put the tools in slightly different locations. It works a little bit differently, but same concept basically is applying. Cool. Just quickly checking the chat here. Awesome. Right. So back to the sketch. I don't just want to, randomly draw sketch or kind of guess where everything is. So that's where we have our project tool. So from our top, okay, I can go and project geometry that exists that I want to reuse. Okay, so under the create, you can click this little drop down, go down to where it says project, and intersect is not the tool we want to use because nothing intersects the plane that we are drawing on, so it wouldn't do anything. We want to use the project option, and we want to project certain edges or certain geometry onto our sketch. So I'm going to say project, and I'm not necessarily going to go and select everything. I don't want to, project that entire face up either. You can see I don't really want to do that. I haven't clicked yet. I'm just hovering in just the right spot for this to work. I actually just want to project certain edges. I've gone into the 3D view again, just so that we can see it is projecting it up there. You can see it's projecting it sort of. It looks like it's going obviously away from it, but it's just because of the view that I'm currently at. You can see that it's projecting what I'm hovering on onto the work plane I'm on. So back to the top, if I go choose this little rounded off edge and this edge and this edge, and you can see they're staying blue once I've clicked on them. Just in a circle, all of these guys in here, freaking easy to just grab them all. Okay, if you select something that you don't want to, like I accidentally clicked on that face, just click on the face again. And obviously I can go around and click on all of the little edges that I want. Now there's a couple more things, but before I do, can you see how it's now projected those edges onto our work plane? That is projected geometry. Now, like I showed you with that circle that we used the intersect tool on, if that geometry were to change, so would the projected geometry. That means that if that whole size, changed, then on the top bracket, the whole size would update as well. So it's quite nice. Project gives us that ability. Now, there's a couple more things I want to do. So obviously on the other side, I want to project this edge and this edge. Now I'm just doing it in 3D here to show you that you can. It's up to you, which you're more comfortable with. But there you go, nicely. I've now projected some edges that I'm going to need. There's a couple more holes in here that I'm going to want. So let's just quickly get our view cube nicely and fixed. Go ahead, click on all these little holes all over the place. Okay, so I'm just running through and selecting all the geometry that I'm trying to project. Okay, and once I've projected everything and I'm happy, I can click on the little OK button. And that basically confirms that what I've projected, what I've clicked on, I'm happy with projecting that information. Okay, there are some more options inside here. For example, this project link, this is basically what links it back to the original geometry. So if the original geometry were to change, this would update. You could untick that so that it doesn't. But it's obviously, in this case, I wanted to do that. If the bottom plate changed, the top plate was changed too. Click OK. And there you go. I've created projected geometry. I'm still inside my sketch. I just clicked OK to finish projecting. So inside the sketch, I still want to create some more geometry inside there, right? I mean, currently we've just got some, stuff projected all over the place. So I want to use my line tool. So here's my line tool up here. Okay, so I start my line tool, and I can go and actually click on that endpoint, and you'll see how nicely it snaps. There it's snapping to the grid, and you can see it actually, if you look at it, it sort of looks like that snap is sort of, lying down on that plane. But if I go and snap to that point over there, you can see definitely it's snapping to that edge. And I want to snap that corner or that little point right across was my, my first click that side and my second click over here. And it's created a line between them. Now, if you remember from the previous session, if the line is black, it means it's fully constrained. So that means it cannot move. And naturally, that makes sense because the one end is attached to projected geometry, and projected geometry is coming from existing geometry, so it can't move, right? So that means, therefore, indirectly, this cannot move either. So I'll do the same on the opposite side, there to here. And as soon as I did that, you would have noticed the internal area would have highlighted blue because it is now a closed profile. Okay. Looks great. Right, I do see something in the Q&A. I think I'll leave that one for...
There is a question in the Q&A that is
Yep.
a bit more of a generic nature than the demo. So I was thinking if we hold that until...
no problem. I'll leave that. Perfect.
That doesn't, the person who's asking, I hope that's okay, Michael, that we just hold it. We've seen it and I'll pick it up at the side.
Okay, cool. All right, so yeah, I mean, now I'm pretty much done with the sketch. I'm happy with this. I've got my projected geometry. I've got the lines that close the sketch to make it actually, a profile. So I can say finish sketch on my ribbon. And now I'm outside of the sketch environment. So now I have a profile that is closed that I can extrude or revolve or sweep or anything else like that. But specifically, we are going to extrude this. Okay, so I'm going to start my extrude tool. Start my ribbon. There's my extrude tool. And I'm going to go and click inside the closed area that I want. So like we've seen, I could go and click inside these, these circles over here, as many of them as I want, but that's not what I want to extrude. So let's just click on them again to deselect them. I want this closed area inside there. So I click, and you can see now it's actually extruding it with all of those holes cut out already for me. The problem is I don't want to go up that much. I want to go down, okay? Maybe like one, I think it is one. Press enter. And now I've gone and I've extruded that, that sketch 1 millimeter. So now I have a top plate, okay, with holes already obviously drilled into it. Okay. Right. So what I can do then is the next thing I want to do is just go and switch on some other geometry that is already pre-drawn for us and just check, have I done this correctly? Maybe I've done this wrong. Maybe I've extruded in the wrong direction. Maybe I forgot a specific cutout, which obviously I have. So let's take a look at that. So we're going to go to, the drone, okay, and we're going to open up this. We're going to expand this, and we're going to go to the airframe. We're going to expand the airframe, and under airframe, there's a little section called hardware. Okay, just like the work plane that we discussed earlier, you have the ability to hide components and obviously make them visible again. So I'm going to turn this little eyeball over here. I'm going to turn it on. I'm going to take a look at my hardware, okay, which is the screws and the spacers and that sort of thing. And I'm going to zoom in and look. I'm not quite happy with that, right? My extrusion has gone the wrong way, okay? So obviously my fault, I typed in the wrong value, okay? But very easily, I can just change that extrusion, okay? So from my feature tree, quite an extensive feature tree at the bottom of here, I can go and find my last extrusion I did. I can right click on it and I can say edit feature. Okay, so I can edit the feature. And instead of it going down like I've extruded it, it should have rather gone up. Okay, now down I said 1. I do want it to be 1 mil still, but I'm going to be going up. So up is a negative value. So it's going to be -1. And that looks much better. Click OK. And there you go. Now you can actually see, well, that looks more like how it's supposed to sit. Okay. Now this could have been something that I only realized on the spot. It could have been something that I knew prior, and I knew to obviously extrude it up or down, depending on how you've modeled your design. Okay. But the point I'm trying to make is that if you have made a mistake, editing is very simple and very quick and very easy. Okay. Right, so I'm just going to turn off this hardware again. I don't need it anymore. Served its purpose. So I'm going to switch it off, and I can look at the actual plate itself. Now, Matt in the beginning earlier today was talking about sustainability and that sort of thing. And it really, I love that sort of thing. I mean, solar power and all that also was a great topic for me. And in terms of, trying to limit waste and that sort of thing, is that this is a drone, and a drone is supposed to fly around. The heavier it is, the more difficult it is, the more battery it uses. So the lighter it would be, the better. Again, in terms of material, the less material we use, the better. So we don't actually have to have these plates, both of these, top and bottom. I'm going to focus on the top one though. But I could, get rid of some of the material. I don't need, such a thick piece of metal or carbon fiber going across there. It could have holes punched out in it, weight reduction, ventilation, whatever the design purpose is. But to do that, I can easily create another sketch. And this time I don't have a work plane, but there are faces in this model. And I could go and click on any flat face in the model that I found. But obviously I want to sketch on this top face. So I'm going to click on this top face. If I wanted to sketch on this face, I could click on this face. And you'll notice, if you look at that grid, the grid is actually changing based on the face that I hover on. Okay. So I'm going to hover on this top face, and I'm going to click. And you'll see it'll create a sketch now on that top, on top of that, extrusion that we've just made. So you can see the grid is sitting perfectly flush on top of our extrusion. So I like to do this from the top. It's a little bit easier to draw. And I'm going to create some cutouts. So I'm going to use my 2-point rectangle. And I'm not worried about the size for this, just roughly over there. I'm going to click. Maybe roughly over there. That looks pretty good. And maybe internally there to there, just a small little cutout. And again, maybe there. I think, which one are we going with? It's snapping in line with the wrong one, I think. That's where we want to be. Okay. There to around about there, I think. Looks pretty decent, I think. Right, so I've created another sketch on those faces. It looks good, but maybe it looks a little bit too, I don't know, pointed. It should have some rounded edges. So we looked at the fillet tool within our sketch. So there's our fillet, and I can click on this edge, and we can see there's a nice fillet applied to it. 8, bit much, maybe 5 would look a bit better. And we can press enter. I can start my fillet again, and click on that corner, that corner, that corner. And all of those can have a radius of 5. So we can kind of run around our model and make it look the way we want. So maybe this guy over here we'll do 2, maybe 3 mils. And then fillet. This one over here again, all of those. All being 5. Yeah. So now I've just rounded off those edges a bit. So I can finish my sketch because there's nothing else I need to do. So I'm going to say finish. Okay. And then I can go and extrude again. But this time I'm going to extrude through an existing bit of geometry. So there's already a solid plate there. So when I extrude, I'm going to say, well, I want to start my extrusion tool and I want to extrude this profile, and this profile. And I don't want to go up, but rather I want to go down. And like I could go down through everything, and you can see how it's cutting out, through all of our plates. Okay. But I could go a certain distance rather, so that it only went through, the one plate. And there's a couple more tools in our dialog box for extrusion that we can actually play around with. For example, the extent type, we can set it to go to the other side of a certain face, or go to a certain face and not further. We could set it to a distance if we wanted to. But let's go and set the extent type to object. And to object is going to allow me to select another face. So I'm going to say to object, and I could go and choose the other side of this, okay? But in my design, that bottom plate needs to be solid because it's supporting a whole bunch of, components. I've put it like that so that there's no shorting on the PCB that's going to be loaded just now. Whatever the story is, there's a purpose for it. So I actually just want to go just to the underside of this plate. So I'll click so that the extrusion starts on the top and stops at the bottom. So it starts on the top face and it stops at the bottom face. And you'll see that'll create a cutout just through a plate. Okay. The operation obviously is set to cut, but there are other options that we could go with. Join would pretty much do nothing. It would just join the geometry together and have one solid plate again. Cut would obviously cut into it. Intersect would keep the intersecting geometry, which we do not want to do. New body would obviously create a new body and so on and so on. So cut is what we want to set it to, and I want to say okay. And it's now cut out holes in that plate. Like I said, weight reduction, ventilation, whatever it be, whatever the reason is. Maybe I realized that there was a mistake. So in the feature tree, I can go back and edit the sketch. Okay? I can just go and find, there it is. I can go and find my sketch, whichever sketch I needed to go and make a change to. For example, this one, right click, edit, and make a change to that original sketch that I was doing. Change it, maybe it's supposed to be 6 mils. That's a better, fillet or a better radius on the edge there. Finish, and you'll see it's updated. That one now has a 6 mil radius versus a 5 mil radius. So you can obviously make changes as you wish along the way. All right, so that is the top plate pretty much done. So let's go and turn on our hardware again. So there's our hardware. Oh, I see a question's popped up. Yes, so when it comes to weight and stuff like that, you can. So you can see here there is a carbon fiber material applied. So if I were to just find this quickly, I think it'll be, just try to remember where this is. I think it's in here. Yeah, let's go over here. And if you go to physical material, we have assigned, it's got steel assigned to it, it looks like. But yes, we can go and assign a material to it. We can also go and edit that material, create our own, give it some density. In this case, there's a lot more information that you can go into for the materials. That will then, yes, come back and affect how the model behaves in terms of stress analysis and that sort of thing. So yes, to answer your question, it would affect the mass, the strength, depending on the material that's been applied and obviously set up. And you can create your own materials. You get a physical and you get an appearance. Just to explain those basically in kind of a very basic, a basic way of explaining it is that, and I always use this method, especially in Inventor, is that you get a physical material. Maybe I'll just right click here so you can see it. You get a physical material and you get an appearance. So your physical material is what it's actually made of and its weight. Okay, whereas the appearance is just what does it look like. And I use the example of you can take a piece of wood and spray paint it gold. Doesn't make it the same weight as gold. It doesn't make it the same worth as gold, obviously. And you can take a piece of gold and you can like detail it and make it look like brushed aluminium or silver. Doesn't lower the cost of the gold or you reduce the weight. So your physical material is its actual material, its weight and properties and that sort of thing. Whereas your appearance is just the spray paint. Okay, whatever it looks like. Okay, cool. So that is our plate, top plate, nicely done. So we can go turn on our hardware, see how everything looks. Is anything in the way? Have I forgotten anything? No. So I can see there we've got holes through the top there to allow us to get our screwdriver or whatever it is, whatever tool we're trying to use through there to tighten those bolts. And we can obviously kind of scrutinize this and decide, is this good? Looks pretty good. I'm happy with this. So here I can go and turn on my camera mount. There's a little camera mount option. Turn this on. Is that good? Does that look right? Are the holes in the right place? Yes, that all fits quite nicely together and it looks pretty decent. The bottom, are they in the right place? Maybe, maybe not. They look like they're in the right place. Cool. Okay. So now that I've got the hardware turned on, I've got that camera mount turned on, and I've got the top plate freshly drawn, I can go down to the other components and I can switch them on. Now I've just grouped them as other components. Okay, obviously there's a lot more intricate design in that, but we can just go switch on our other components and take a look at our final finished model. Yeah. So then we've got the base of the drone on which everything sits. We've got our plate that we've drawn at the top. Okay. We've got the camera at the bottom. You know, all the other components have been switched on. The visibility has been re-enabled, so we can see it. Fusion, I'm not going to get into this. Fusion has the ability to constrain things outside of a sketch environment using your joint tools. Okay, so if I were just to expand this, just to give you a little bit of a show on where it is. Okay, there's joint tools, there's joint and as built. Joint allows you to join multiple components together in an orientation that you like. As built does the same, but it's already in its place, you know, already sitting exactly where it needs to be. Okay, so if it's already sitting where it needs to be, you use the as built joint and say, okay, well, if this and this is already joined or already positioned perfectly, we just need to constrain it in place, either rigid, rotational, or whatever it is. Okay, now because they are not constrained, I can actually hover on this battery, this face of this battery over here, and drag it off to the side. And maybe this propeller as well, drag it off to the side. So nothing is actually constrained in this model. Okay, but it's also obviously for us to play around with. And it's nice because I can actually drag things away and sort of see what I need to see. And if I take a look at that plate that we've drawn there quite nicely suits its purpose on top there. Okay, it provides a big enough platform for that battery to sit on. So if I just revert my position, it's a big enough platform for that battery to sit on. Ideally, we'd probably want to strap that battery down somehow, but that's not at this design level. That's the next level. But yeah, I mean, it looks pretty good.
Yeah,
the last thing that
sorry for jumping in again, Chris, and interrupting
yes,
you, but I saw that there was another question in the chat about the
cool.
blades.
Drawing the blades, so you could use the sweep tool. You could use a number of different tools. I mean, for example, if a loft tool could also work. I can see there the way this blade has been drawn, there's a number of different tools that have been used. So let's just look at this, for example, just to get a good angle from the side. Okay, so the first thing I can think of that they've done here is maybe rather to start a new part instead of messing this one up. So let's say they've drawn a sketch on the side. I'm going to go through this pretty quickly. Let's say they've gone and drawn a rectangle. So that is the start of our blade. Okay, let's click on finish. Let's just get this thing out the way. There you go. Let's click finish. Okay, so there's the start of our blade. It's going to start there. Okay. Then we're going to have another part to it. So maybe we're going to use an offset plane. Okay. And from there, we're going to offset it outward. Let's just go a little bit further than that. I'm not worried about sizes and lengths and all that. I'm just trying to create that basic geometry for you. But I could create another sketch on that face. Now, I didn't show this in the previous session, you know, the loft tool, but since the questions come up, I will. But I could go and create another rectangle, 3-point rectangle from there to just make it a little bit interesting, like that. It looks terrible because the spacing is not the same, but it's good enough. You get the idea. Let's take the whole thing, actually, move it down a little bit. Okay, so the one end is going to be a little bit bigger than the other end, but you're going to get the idea. Now that I've done that, I've got a starting shape and I've got an ending shape. 2 different planes, 2 very basic sketches. But I can use a tool called the loft tool. And you can see there from that little illustration, the loft tool is designed to take 2 sketches and kind of fill in the geometry to join them together, to blend them together. So if you were to look at that, the square to round, that if you guys have any idea about HVAC systems, I'm not expecting you to know everything about it, but if you're able to, you know, understand what an air terminal is, that's where the air comes out, you know, in a building, there's that duct that is going onto that air terminal. Maybe it's square, maybe it's round, maybe there's a point where the duct was square and now needs to be round. You could use the loft tool to create a square to round transition piece. We're using it obviously to try to create this like little propeller blade sort of thing. So we could say loft, and we can go and choose our first profile and our second profile, and you'll see how they loft together at that bit of a twist. Now, obviously, if I'd drawn this a little bit better with proper sizes and stuff, with better angles of rotation, you'll be able to see there's that propeller sort of kind of being made out. Okay, I could then create another sketch. okay, on one of the faces. In fact, let's actually just do this. Create a offset plane up a bit. Yeah. Can use the edges and make that plane a little bit bigger so I can see it a bit nicer from the top. Does that look pretty decent? I think it does. Just to give us an idea, just to break it down a bit more, I could go and sketch on that plane. And what do I want to do? Well, I want to create a shape that sort of looks like the propeller. So maybe something I could project this edge if I want to snap to it, but I'm just going to go inside here like this. Let's say it's rounded off like that. Maybe it's got a bit of a slant to it. And then the last piece has a bit of a slant. There you go. That looks pretty much like the shape I want. Obviously, I'm just guessing what a propeller would look like from memory here. And I would say extrude that shape through the other one, but not cutting, because that's going to cause a problem. Rather, we can set our operation to intersect. And now we're intersecting and keeping just the geometry that I've wanted. Yeah, so obviously the person that designed this drone, and I'm not trying to claim credit for it, they spent a bit more time than I am, and they've created a much better looking propeller blade, but basically using that same concept I've just shown you. One sketch, another sketch, lofted together with a bit of a twist there. You can see it's created much thinner, also looks pretty good, and then a decent little cutout intersection. Yeah, cool. So the last thing I wanted to look at then is this antenna on the top here. Okay. To be honest, I've never seen an antenna that looks like this. I haven't owned many drones, to be honest, but I've never seen an antenna that looks like this. It looks pretty fragile, if you were to ask me. So I think we need to give this sort of, some sort of protection on the top here. So just to quickly run you through what I've done, I've created a work plane in the right place. And in the model that you guys download, that work plane is already there, okay? But by all means, you're welcome to right click on it and say delete. We still need it, okay? But I've just deleted it. We can use our construct planes, mid plane, okay? There's a number of other ones you could go and use, but I'm going to use mid plane. And mid plane, if I go and find, just try to get to a decent little angle over here. If I go find that edge face over there, select it, I know that on the other side, about over here, I should be able to see it, is that other face. And I can click on that. And I've gone and created a plane that is perfectly in between those two. And say, okay. And then just obviously stretch that out a bit so I can see it a bit better. But very quickly, very easily, I've created the plane exactly where I need it to be, in the middle. Okay, so just to show you, it was very quick, very simple, but it is already there for you. Okay, so what we want to do then is we want to create some sort of, cover for that. And you can think, well, what are we going to do? Are we going to create like a box, on top of it that kind of just sits and rests on it? No, maybe not. Maybe we should rather create some sort of like a cap, okay, like a deodorant cap or something shaped like that to put on the top. So to do that, we can use our revolve tool. So we looked at the revolve tool with that, to kind of create like that wheel looking shape. But here we're going to create a cap similar to this. Okay, sort of similar shape to this. Right, but so to do that, I see another question. How do you draw the wires? So the wires would have been done with a sweep. You can see there, trying to think, so I guess you could use a loft as well, or an extrusion maybe even. There's so many different ways. Okay, for a sweep, for example, just to quickly get into this. So I'm going to do a basic version of it, but a sweep, let's just say you've got a bendy line. Okay, little curved flat on the ground, bendy line. And I've gone and created which one do we like to use? Along a path, it's this guy, a certain plane at the right spot. Okay, a sketch on that plane. I go and create our circle. That's what we're going to use for this. Finish. Again, I'm not using all my constraints and everything like I should be, but it's just for quick purposes to show you. There's a sweep tool. I can say sweep that profile. Okay, it's not picking up my profile. Why are you not picking up my profile? There it is. Now, here's my profile, and my path is obviously this. And then I could create the shape that I needed it to follow for the wire. So like I said, just a very basic flat on the ground one, nothing too fancy. It would take a bit more time to set up those, quite interesting little intricate antennas. But yeah, using your sweep tool and your planes, you could do that. Cool. Right, so we're going to create a sketch. Okay, we're going to create a sketch on that antenna work plane. And from here, just rotate a little bit here so I can see, I need to project some geometry so that I can start working with it. Okay, so under the create drop down, we can go to project, go over to the project button itself. And we might want to project some edges, and I only really need this circle. And you'll notice that that red line appearing, that is going to be the projected edge. If I project this face, it's going to project that edge at the top, as well as at the bottom, it'll project there's another edge at the bottom. We don't want that. We just want the one red projected line up at the top. I can say okay, because that's all I need. All right, and you can see there, I've nicely, I can just find it here quickly without holding shift. You can see they have nicely projected it across. Mouse is all over the place today. All right, so I can go back to the front view. I just look at it nicely from the front view. Here's my projected edge. So I can draw a little shape around it. Now remember, we're going to revolve it. So technically we only need half the shape. So I'm going to start my line tool. In the middle, I'm going to snap to the middle of our projected line. You can see it's snapping quite nicely there. It's not really jumping all over the place like this, but it's snapping to the center. And we get that little triangle snap popped up. But I can click on that and I can go up. And I can go up a specific distance if I want. I think it was 17 was a good number. Okay, this dimension, maybe it's in the way, so I can drag it to the other side. Okay, but it's perfectly placed where it is. I can create another line. I'm going to go across over here. And I think it's 15.5. I can't remember exactly what it is now, but there's a value of 15.5. And I can go and create an arc. Now, I haven't shown the arc yet. Okay, so under create, I can use an arc, and I could use a boring 3-point arc, or I could use our center point arc. So our center point arc is quite a nice one, especially for this situation, because I know the center point, and I know the start, and I know the end. Our center point would be here. Our start would either be this side, and obviously the end being the opposite side. So center point arc asks me for my center point. It says place center point. So there it is. I then go and choose the start point here. And then I just move my cursor, and you can see there, I got my maths quite right, is that the 15.5 is where I'm going to end. And if you look at that, our arc actually sits quite nicely. Okay, it's a perfect arc. I'll press escape because I don't need any more. Now, if I were to revolve this, and I'm going to, but I'm going to come back to this step in a minute. But if I were to revolve this, so I'm going to say finish. Okay. We know it's turned that lightish blue color, so it's a profile, meaning we can actually do something to it, either extrude or revolve. Extrude wouldn't work. We want to revolve. We want to revolve that profile. It is the only profile, and that's why Fusion has actually picked it up for us and said, well, this is clearly your profile since it's the only one. What is the axis that you want to revolve around? So the axis would be this internal edge. But what it's going to do is it's going to cut. Okay, because it's seen that, okay, well, that profile is a solid item. There is stuff in the way of the solid item. So obviously we are trying to cut that out. And no, we're not wanting to cut it out. But the problem with this is if I do say join or new body or new component, whatever I go and choose, the problem is that it's going to sort of, interfere and intersect and actually clash with the existing aerial. So I'm going to stop us at this point. I'm going to press escape. And I'm rather going to go back into that sketch. Okay, just get myself out of the way here again. I'm going to go back inside that sketch. And inside that sketch, I'm going to just change it up a bit. So I'm going to rather go and use the offset tool, so my modify tools. And I want to offset that edge inward, okay, a little bit. Now, currently it's chaining, it's doing the chain selection, which is fine. I can delete stuff afterwards, it's not a problem. But if you wanted to, you could go and turn off chain select, in which case, if I were to do that again, chain select off, it'll only select that one edge that I've chosen. Okay, so either way, it doesn't matter. But I'm going to go up to about here. I think maybe we'll put negative 0.5, I think is a good value. I'm then going to go and delete this line over here. I don't need it at all. This one over here, I do need, so I'm going to keep that. Actually, I do want to offset that as well. Offset this up to 0.5. We're going to go use that tool I told you about, trim, to trim out some extra little pieces of line over here. So trim, cut that, cut that. You can see there I've gone and cut that out. Okay. That area inside there is not blue. And it's pretty obvious why, because the shape is not actually closed. So if I go this side, it's open. So I use my line tool, and I quickly just close that off. Okay. And at the bottom over here, I'd probably want to extend these across, maybe, kind of take it to, it's got a coincident constraint, but I would want to maybe take that across to somewhere like over there, possibly would look a bit better. So it actually looks like it's sitting on something. And draw another line from there to there. And as soon as I do that, you'll see it turned blue, turns a lightish blue, because it's now closed. And I can say finish sketch. I go look at this. There's that blue infill. So if I started my revolve tool, picks it up, my axis, could go and use this edge, and it's created a nice little revolve around our aerial. Now, I know it's a nice revolve and a cap because I drew it that shape. I know it's not interfering with any information, and maybe I'm going to go set it as a new component or whatever I wanted to. I'm going to set it as a new component. I'm also going to, just because, just for the purpose of the demonstration, I'm going to set the angle of the rotation to something maybe like 180 or maybe like 200 degrees, or 270 might be a bit better, look a bit neater there. And because I've told it to rotate 270 degrees, it gives us that little window on the side here where we can see in. And I'm going to click OK. And you can see there, I've created that nice little cap for the antenna. Now, hopefully it's not a lead cap because that would probably interfere with the signal. But if it's a nice little plastic cap or something like that, that wouldn't affect with the signal, this would protect it quite nicely. You wouldn't have to maybe do a revolve. I guess you could do like another wire frame, whatever design you wanted to go with. I've gone with like a little revolve cap on the top there to protect it. But yeah, that's pretty much the revolve tool for the cap. Any other questions on that? Otherwise, yeah, I mean, that's pretty much our drone model. The last thing I wanted to do is just show you the change of workspace, to just quickly go over to the render workspace, just to show you that Fusion 360 can take my pretty good looking drone and make it look a little bit better. Cool. I see there, obviously, Ranzabing's put my email address. So if you guys do have any questions, you're welcome to send me emails. You don't see how the sketches for the antenna can be on the same plane. What do you mean? The sketches for the antenna, to make the antenna, to make that shape. Just get rid of this. The wires. So if you look at it, all of those wires are actually technically flat. So what it's doing, if I were to just quickly start another sketch, I think I'm understanding correctly. Let me just put this to the side over here. So what's basically happened is they've drawn their wires like this. Let's go, I think it was like this. No. That. Like this. Create just a 3-point arc quickly. To be too perfect. Looks good. Wait, back inside our sketch. Forgot something up. quite that much. Yeah, I go quiet when I'm thinking, guys. Looks pretty good. Sketch on that plane with a little circle. There's our sketch there. 3 mils would be a good size. Looks like it's going to work nicely. Sweep that profile along this path. And that's basically how they've done one of the wires. If you just look at the rest, they just did on different planes. So this one, yeah, it continues. That one's been done on that plane. That one's been done on that plane, that plane, that plane. We can go and project and use, you know, plane at angle. So plane at angle, there you go. Maybe go and create like a 45. Say 45. And go sketch on that plane. I can draw the same shape again. I'm not going to project because it's not going to look quite right because of the angle. Let's just do that. Arc, 3 points. Bullet. Can't remember what I said, probably 5. Hope I don't clash. It's probably going to clash if I'm looking at it, but it's okay. Just for illustration. Yeah, do we have a clash? Hey, look at that. Perfection almost. Yeah, so then obviously they've just done that basically with a much nicer way of doing it, but with proper accurate sizes and dimensions and values. And that's how they've created their intricate little antenna. Cool. I know they're using just very basic tools. You can make something look quite complicated. And that's basically what the idea of this whole model was, is that just small little tools that we've gone, okay, it's projected, I can't move it, but small little sketches and projecting and cutouts. And we've actually created the platform for probably one of the most important components to sit on. So yeah, cool. So I'm just going to revert so that everything goes back to where it should sit. And I just want to lastly switch over from the design workspace to the render workspace. Now you'll see there's a couple other workspaces in here. So there's generative design, animation, simulation. I know this morning a lot of those were spoken about, so I'm just going to jump straight into the render. Switch over to our render environment, and it'll take all the materials into account and all the appearances, and it'll actually show us what our model would look like. So clearly from this, you can see that there's like a stainless steel or a chrome material or shiny reflective material applied to these, the propeller caps at the top there. The carbon fiber looks pretty good. The camera looks terrible. There's no glass in here, but let's not shoot the designer. The wires, the actual shine on the electrical wires looks pretty good. This is normally that like very glossy plastic, to protect the components from water or whatever. Yeah, but I think the best parts of this model probably are the plate and the antenna cap. That's a non-biased view on this, but yeah, it looks pretty good. Looks quite decent. Cool. All right, guys. So that's pretty much it. Any further questions?
Really nice. Thank you, Chris. I think it looks like there's a few questions coming in now. So
yeah, I did see that the standard parts library. So not really, to be honest, it doesn't have that big of a library. I know there's a contents library inside Inventor where it's got nuts and bolts. Something that I have been looking at quite recently is I found this, and I haven't given it much looking at, but there's something called master. Try and find where it is now. there. I think it's this one there. Mastercard components. This is something that I actually am currently looking into. I want to, follow it up a bit more. At this point, I'm not clued up enough to go into it. But yes, I have seen another guy. I can't remember his name now. He actually did this presentation last year. Maybe Thomas, you'll remember him. Can't remember his name off the top of my head. Brian, I think it's Brian. It's probably not Brian, but I think he did make mention of the Mastercard components. But myself personally, I haven't looked into it.
Right, and then I see that there's a slightly aligning question in the Q&A box about sourcing the electronic components of a drone model like this. Don't know if you have any input on that, whether that's
I don't have any experience or any input on the electronic side of things, on the PCB side of things. But I mean, I'm willing to stick my neck out and say that Fusion is quite an intelligent software that I'm sure you could go and assign pricing to components and stuff like that. Through the materials. I mean, the amount of information you can give into the materials, I'm more than likely going to be right when I say that yes, you can go and assign costs to components and stuff like that. Yes.
Yes, and there are libraries, but I don't know how regional they are. I know there's some setups for the US in particular, but that's maybe a question we can turn over to the Autodesk community. So Autodesk has quite a lot of strong community managers that typically are really good at helping to find answers like that. So we'll take that with us and see whether we can get any input from them.
Yeah, perfect. And then lastly, I see here there's a question about Fusion 360 being compared to Inventor with iLogic. No, there's no programming side of Fusion. So in terms of iLogic, no, Inventor's got the iLogic side of things, not Fusion.
Perfect, thank you. Yeah, all of you feel free to add more questions. There was another question which wasn't directly related to the example here, but maybe Chris, you would have some good input on this as well. And apologies, Michael, for letting you wait this long. It was posted just before the demo was started. But the question is, I teach primary and secondary school students digital skills.
Yes.
What tool is best to introduce them to 3D design?
When you mean what tool, like as in like what 3D package?
Yeah, well, I would assume, I imagine that the question is related to, is Fusion suitable? Maybe.
Definitely.
Yeah.
So to give you a bit of insight or a bit of a background on me a bit further is that recently I did train a couple of students up in Joburg. I'm not going to mention the schools purely because I can't remember all of them, but they were looking specifically at Fusion 360. They were at a very fundamentals level. They were, I think, grade 10 learners. And it's nice to know that the schools are actually incorporating Fusion 360 into the curriculum. Sort of, they're trying to help the students out and say, well, if you're trying to create 3D components on a drawing board, a lot of students actually struggle with visualization and that sort of thing. So Fusion 360 is a perfect software to kind of create those actual 3D components and show them, well, look, I'm trying to get a top view. So let's click on the top of the view cube, and then you get a top view and a front and a side. And then on the drawing side of things, there's sections and details and orthographic what you call auxiliary views and that sort of thing. There's a whole bunch of tools like that. So Fusion is a great tool, and obviously with the whole education system, we can actually get free licenses for it, and the students themselves can get a license for Fusion and go on and try out things for themselves and practice on their own. So yeah, I mean, Fusion is a tool I would recommend for that.
Thank you. That's good advice. And I think the only thing I would add is for the really young children, more of primary age, there's also Tinkercad from Autodesk, which might be a suitable kind of entry point. So I'll just put a link to the resources that are available. It's obviously not, I would say it's really starting out and gaining initial feeling and steer for the concepts, but then I fully align with Chris on the the high school age, etc. Then Fusion is actually a really good tool to get started with.
Yeah,